the integral from 0 to 1 from the square root of 1 plus x squared dx, and they say it's less than or equal to 0 to 1 plus x dx. Very good. So this is one of the three properties that we looked at, right? One of the properties was if the function is positive or 0, the area will be positive or 0. The second one is if a function is under another function on an interval, obviously the area under the first one will be smaller than the area under the second one. And if a function is between two numbers, the area below the first number is less than the area under the graph of the function is less than the area under the bigger number. So in this case, obviously I have that situation in which I have to show this. And once I show this, then I will show this. So that's the idea. So where's my starting point? So my starting point must be with x. That's what I know for sure, right? From the very beginning. I know that x is somewhere between 0 and 1. That's what it says. If x is between 0 and 1, I'm asking myself, when x is between 0 and 1, where is x squared? Between 0 and 1. If x is a number between 0 and 1, x squared is also a number between 0 and 1. The smallest is 0, the largest is 1. Is that okay? If you have in your pocket anywhere between 0 cents and 100 cents, no, I'm sorry, yeah, and $1, if you square that, you still have between 0 and 1. Because 1/2 squared is 1/4. 1/3 squared is 1/9. So no matter what you square between 0 and 1, the result will always be between 0 and 1. So now, here's a discussion. If I have numbers between 0 and 1, which of those two, x or x squared, is bigger? X is bigger, correct. So then I have that x squared is less than or equal to x. Adding 1 to both sides is not going to make any difference. They are both positive because x is between 0 and 1. So then I can take the square root from both sides. This is not a legitimate operation unless I'm sure that the left-hand side and the right-hand side are positive. I cannot take the square root from an inequality, from both sides of an inequality, unless I'm certain that both sides are positive, and they are. So then I'm done. This is my f, this is my g. So now I'll say the integral from 0 to 1 from the square root of 1 plus x squared dx must be, by one of the properties that we just discussed, this.
That's what you had to do?
Yes.
I had that written raised it all. Cool.
Okay. I thought there was something else before we look at the midpoint. There was something else?
We can do a midpoint.
No. What was the other one?
There's 56 on
Yes.
3.
We just did that. Oh, so this was done on this page?
Another 56. Yeah.
Another 56 on 395. Okay, let's take a look. 56, 56, 56. Okay. We have g of x, which is the integral from 1 minus 2x to 1 plus 2x t sine t dt. Is this the one?
Yes.
Okay. So no one can ask us to do anything else but differentiate this function given in the form of an integral. There is nothing else. So remember, I have to break it up because if the lower limit is not a number, I can't differentiate. So 1 minus 2x to, let's say, 0, t sine t dt plus the integral from 0 to 1 plus 2x t sine t dt. So this one is ready for differentiation, but this one is not, and I'm going to reverse the limits of integration. So I have negative 0 to 1 minus 2x t sine t dt plus the integral from 0 to 1 plus 2x t sine t dt. And now this is ready to differentiate. So then g prime of x equals negative in front, 1 minus 2x sine of 1 minus 2x times the inner function prime, which is negative 2. Now I differentiate this one plus 1 plus 2x sine 1 plus 2x times the inner function prime. So Paul, do you have your checklist?
Yes.
Okay, because I have to take it.
Okay.
That's why I was working on problems. Sorry about that. I don't mean to rush. That's okay. So all I have to do is just rearrange those and put 2 in front, and negative 2 times negative 1 would be 2. Just the checklist.
Yes, we can. I found. Do we have to flip it and make it negative?
Absolutely, because you cannot integrate. The fundamental theorem of calculus part 1 says integrate from a number to x or to a function. So otherwise you cannot differentiate.
Gotcha.
And this number can be anything, it doesn't have to be 0. Very good. Okay, is there anything else before you look at the midpoint? So I would write one more step here. Just oh no. No, because you cannot simplify, you cannot do anything.
With the first factor, 1 minus 2x, you can't with sine. This is 1 minus 2x times sine to 1 minus 2x. So it'd be negative sine to 1 minus 2x minus or plus 2x sine to.
Yeah, but you will not be able to simplify because this is sine of 1 minus 2x and this is sine of 1 plus 2x. There is nothing you can do anyway.
Alright, so, but I mean, if you did, is that
No,
okay?
yeah, but I will not mess with this. This is awful.
Okay.
Even if I distribute, I will not be able to simplify.
Oh, that's not distributed.
Yeah, there is no need. This is good enough.
Okay.
Next question. Did we have anything else? Okay. Yep. Okay. So, Nico, do you know which problem?
Yeah, it's on 383. The checklist had number 12, but we can do 11 as well.
11. Okay, use the midpoint rule with a given value of n to approximate.
Can we just do one?
That's fine. Okay, so this is the integral from 1 to 5, x squared e to negative x dx. And we are given 4 subintervals. Did I copy it correctly?
Yeah.
Good. So here's my interval. 4, right? 2, 3, 4. So 1, 2, 3, 4 subintervals. The midpoint here is 1.5. The midpoint here is 2.5. The midpoint here is 3.5. The midpoint here is 4.5. So the area M4 is approximately, since the width of the interval is 1, no problem. You have your checklist. Is that a yes? Okay. So 1, I shouldn't even multiply by it. F of 1.5 plus F of 2.5 plus F of 3.5 plus F of 4.5. And I just have to plug them in.
Yeah.
So what I would do with this,
I just put that in there.
so I would go to,
Y equals.
well, actually,
You can do, what I did was Y equals, but then do the equation and then
Pull the
do
variable out.
Yeah. And then add them together.
I would like to use a list.
No.
Okay. Okay, so I would like to add. You have several ways here. So one way would be to create a list with those numbers: 1.5, 2.5, 3.5, 4.5. apply the function, and then sum them up. So I want to edit, and I'm going to put 1.5, 2.5, 3.5, and 4.5. And in the right column, up at the top, I put, this is x squared e to negative x. Okay. I will put list L1 squared multiplied by e, and that was negative, right? Okay. In parentheses, negative list L1, and then I press enter and I get all of them. I'll show you one more time all this, and then yes, and then I'll go to stats, and I want one variable stats on L2, and I get the summation, and you'll recognize that. And here it is. Here's my sum, 1.6099499229. So I didn't have to calculate anything by hand. So this is, and because delta was 1, otherwise I would have put in front delta blah blah blah. Delta times this sum, but delta was 1, delta x. So this is 1.609949. Do you want me to show this again?
Sure.
Okay, so first we go to second list. No, sorry. First we go to stats and edit. Stats and edit. And then I put in 1.5, 2.5, 2.5, 4.5. And then I go to the right top, highlight L2. And if you highlight L2, sorry, you will put in L1 squared with second and 1. Second and 1 will create L1. So second L1 squared multiplied by second and e to the x. I always put the power in parentheses, minus L1, close the parenthesis. And when you hit enter, it will calculate all these numbers at once. You don't have to do it by hand.
You're recording, correct?
Yes, I am. So let me check. Yes, I am.
One of them ended short.
Yeah.
Like when from the 19th, the second video ended short.
I know.
Yeah.
I know, and I know what happened because I deleted all the videos, but they were still there. And once it got to 10 gig, it stopped. Yes, about half an hour. I know. I was just talking to Paul about it last week. So, and then get out of there, second and quit, and go to stats. Now go to calculations, one variable stats, but don't forget to put in parentheses list L2, because otherwise you will calculate it on list L1 by default. And when you hit enter, you will have the summation notation, which is the sum of all the elements in L2.
You can also just do sum of L2, which is under the list option.
Absolutely. Okay, what else am I supposed to do right away? Problems.
Oh, I thought you were this problem.
No, whatever you need.
Ooh,
Yes.
this 68 on 405. I'm pretty sure I did it.
68 on 405.
Yeah.
Thank you. Thank you. 68, 405. 402, 403, 405, 68. 68. Okay. So the water flows into and out of a storage tank, a graph of the rate of change of the volume of water in the tank in liters. Okay, is shown. If the amount of water in the tank times zero, okay, is that. Use the midpoint rule to estimate the amount of water in the tank 4 days later. So from the graph, I would divvy it up into as many.
0.5.
Yeah, that's fine. So I will still use potentially the midpoint because it's the best, but it's an approximation anyway.
So use
Yeah.
the midpoint rule,
Yeah.
and I did.
Well, all the left or the left or the right, because the best one will be the midpoint, but
That's the one I did.
that's fine. So you just have to estimate it.
If you did 4 intervals with the
It's
midpoint,
fine. It doesn't say how many.
All right.
Any estimate is acceptable.
and then you just whatever you get as the answer, you add it to 25,000
Because that's what they have.
because that's what it starts at.
Yes.
Yeah.
Good. Anything else?
Yes.
Yes.
I don't know yet, but yes.
Good. Next question. Anything that you worked on? Anything that you would like to look at?
Can I see my paper real quick? Uh, 8 and everything in 5.1. 8, 14, and 18.
8, 14, and 18.
Yep.
Okay, very good. So let's take a look. Right, so I think we discussed number 8 last time, didn't we? Am I wrong?
What page?
369, the one with 1 plus x squared, and 3 subintervals and 4 subintervals. You just determine the lowest one and you determine the upper one. One with the left most point and then one with the right most point. It depends on the function, however. Sometimes the one on the left will be smaller. Sometimes the one on the right will be smaller. So the same idea with this.
Can you go over it?
Right, yeah. So you have this function, x squared plus 1, and you have negative 1 and 1. So if you're using 4 subintervals, you have negative 1 and 1. This is negative 0.5 and 0.5 and 1. So if you're using the leftmost point, you will have 0.5, which is the width of the interval. So the area with the left 4. 0.5 times f of negative 1 plus f of negative 0.5 plus f of 0 plus f of 0.5. If you have a with the right 4, you have the same thing, 0.5, but you start at this. F of negative 0.5 plus f of 0 plus f of 0.5 plus f of 1.
Let's say n equals 3.
So you have n equals 3 and n equals 4. I started with 4.
Okay.
And then you do the same thing with 3.
Negative 1, 0, 1.
No. If you have 3 subintervals, then this will be negative 1 divided by 3, and this will be 1 divided by 3. No. You have this interval, you have this interval, and you have this interval. You have to divide 2 by 3. So this is 2/3, this is 2/3, this is 2/3. So you will have 2/3 in front, f of -1.
2/3?
Yeah, it's minus.
The width of the interval
One
is 2
minus
units, and you are dividing by the number of subintervals.
B minus N.
So so delta x is b minus a divided by n, which is 2/3. So this will be your delta x this time. So this will be 2/3, and this will be f of -1 plus f of -1/3 plus f of 1/3 for the left. Now for the right will be f of -1/3 plus f of 1/3 plus f of 1. Exactly like we did here. Is that good enough? Or you want me to write this? So it's the same thing that here you have 4 subintervals and here you have 3. Better? The other one you said was 14. Let's take a look at 14. 14. The speedometer reading for a motorcycle at 12-second interval are given. Okay. Estimated distance traveled by the motorcycle during this time period using the velocities at the beginning of the time intervals. So it's basically the same thing. It's delta x, right?
It's the first 4 and then the second 4? Or the first 5?
So you have between 0 and 12. So you will have f of 0, which is 30, plus f of 12, which is 28, plus f of 24, which is 25, plus f of 36, which is 22, plus f of 48, which is 24, multiplied by 12 seconds. Now, at the
Next
end,
one you start with 12.
right,
Okay.
exactly.
Okay.
And let's look at 18. The velocity graph of a car accelerating from, okay, over a period of 30 seconds. Estimate the distance traveled during, again, we are integrating.
Can
This
you
is
go
the-
back to that one for a second?
I'm sorry?
The motorcycle. For part C on that, it says.
Yes. Are your estimates in
Are your
part
estimates
upper and lower estimates?
I said they weren't because the function changes slope, it seems, at some point. So then it's not a pure
It's
upper
not
or lower limit,
consistent.
right?
That is true because it goes up and down. I see from 30 to 28, from 25 to 22, 24, 27.
Okay.
So are your estimates in part A and B upper and lower estimates? Yeah, you can say, right? I had to read the question one more time.
And 18 would allow for an upper and lower estimate since it is consistently.
Yes,
going above.
yes,
Okay.
yes. Estimated distance traveled during the time period. So again, you can use, if you want 3 subintervals, or you can use 6 subintervals, whatever. Of course, with 6 subintervals, you are closer to the truth than with 3. So if you use the leftmost point, then you will have 0 times 10 plus f of 10 times 10 plus f of 20 times 10. If you use the rightmost point, you will have 10 multiplied by f of 10 plus 10 multiplied by f of 20 plus 10 multiplied by f of 30. If you use the midpoint, then you'll have the base, which is 10 times f of 5 plus 10 times f of 15 plus f plus 10 times f of 25. And you have to estimate them from the graph. And they don't appear to be too difficult to estimate roughly. But it's an estimate, no matter what. Okay, very good questions. What else would you like me to go back to? Yes, Nico, please.
Page 414, 16.
Yes, 414. 414. 64. Yes, I thought we did it last. No, we didn't. We did the other one. Yes, yes, let's do it. Let's do it. The integral from 0 to a x the
Did we
square.
do this one in class? No, we didn't send it. Okay.
So the integral from 0 to a from x the square root of a squared minus x squared. Very good. So of course we are going to denote by y or u or t, whatever you want. It doesn't matter. It doesn't have to be the u substitution. It doesn't matter really. Good, minus, right. So dy equals negative 2x dx. It's not a problem to make up a negative 2, multiplying and dividing by negative 2. Is that clear?
Why you do that? Like, why you have to multiply by?
Because I have this in the problem, but I'm missing this piece. I have to make it up.
Yeah, but why would you?
A2 is a constant, right? So it just becomes 0.
Correct.
Yes, a is a constant. We can have two variables. And it's clear that
Why couldn't you just leave dy like the x dx? Why would you have to multiply by?
Because you're getting the derivative.
because dy for this substitution is this. I can't play with that. This is what I have to have in the integral in order to move it from x to y. If I don't have this, I can't continue. So I have this piece. I have this piece, but I'm missing this one. A negative 2 I can make up.
And that's just the derivative of.
That is the differential. This piece now becomes dy. There is no integral without delta x, right? But in the integral, we write it as dx. So if I don't have dx, I cannot put the integral symbol. If I don't have dy, I cannot write the integral symbol. Is that better? Yes? So once I use this substitution and I find the dy, I have to have it here. I do, partially. I don't have the negative 2. But remember, negative 1/2 times negative 2 is 1. So I put a negative 2 inside the integral, and I put a negative 1/2 outside, because I'm allowed to take a factor outside. So I could have put both inside to show you the 1, but I want this one outside. I can put it inside, but I still have to bring it outside. Is this okay so far? So, and this piece is the square root of y. So now I can move completely to x. So y to 1/2 from x to y. Not so fast though, because I can't copy the limits of integration. Not allowed. So when x is 0, the bottom is a squared, bless you. So, and this is 0. What I would like to do here is write 1/2 the integral from 0 to a squared y to 1/2 dy. Yes?
When x is 0, isn't y still 0 because it's still multiplied by it?
When x is 0,
Oh,
a squared minus 0 is a. I'll rather go back and check. Anything is possible. Oh, no. It has to be in the substitution. The function has nothing to do with that. So this is 1/2 y to 3/2 over 3/2 from 0 to a squared. I flip and I get 1/3. And then the square root of a squared is a to the 3rd. And when I plug in 0, I like it. It's 0.
So why is that one 0?
What do you mean by 0?
The
Lower limit?
yes.
So,
Shouldn't it be a squared minus a?
so when
Oh, it's a squared
when
minus a squared. We're good.
okay, I'd rather go back and check because you may see something that I don't. Okay, anything else? Is there any question or any type of problem from in preparation for test 4 that you would say I need to see another one?
Will you arrange this?
Yes. Yes? Good. So let's choose a function for the Riemann sum and an interval. And remember, you cannot say sine t because we're not going to be able to do it. We only have linear, quadratic, cubic for the Riemann sum. We don't know anything else. So
What is this? 8x cubed minus
you said 8,
8x cubed
correct?
minus 14x.
That's it. Good. The interval.
Uh, 0 to 4, I like it.
We said 3 or 4? 4. Fine. Good. We need 3 preps. The first prep is
No, but
good, which is b minus a over n. I'm sorry, xi. It's the next prep.
0 plus delta xi,
Good. Since it's 0, then what do I have to write?
4i over n.
4i over n. Awesome. And then,
F of xi.
very good.
Can you go over how you determine xi again?
Yes. 0, 4. x1 is 0 plus delta x. x2 is 0 plus twice delta x. x3 is 0 plus 3 times delta x. xi is 0 plus I delta x.
So,
So you're literally just
I remember,
multiplying both x
it's
by I.
always the lower.
But do you see the pattern?
plus
Yes, I see why. I was just saying,
Yeah.
while doing.
But when I is 1, I get this.
It was like 2 to
With
4, it
1.
would be 2 plus
When I is 2,
delta.
I get 0 plus 2 delta x. When I is 3, I get 0 plus 3 delta x. So that's why the general term is 0 plus I delta x. Is that okay? Is this okay? Moving on. Okay, so then 8. So f of 4i over n equals 8 times 4 cubed I cubed over n cubed minus 14 4i over n. So 4 cubed, 64 times 8. Okay, I see the calculator is running. What is okay? I cubed over n cubed minus, is it 56? I over n? Okay, so then we have all the preps ready. So this is the integral from 0 to 4, from 8x cubed minus 14x dx, which I will calculate just to make sure, so I don't go crazy later. So this is 8x to the 4 over 4 minus 14x squared over 2, from 0 to 4, 2. So I'm only plugging in 4 to the 4th minus 7 times 16. So if you want to give me this number, then so 2 multiplied by 4 to the 4th power minus 7 times 16. Good function, good interval. Good, so I know what to expect. So this is also definitely equal to limit sen approaches infinity from delta x that I will put in front, 4 over n. And now I'm going to put the sum of the first term, which is 512 over n cubed, the sum of I cubed, and minus 56 over n, the sum of I. Just in order to try to cut back on writing a little bit. Are you with me so far? Yes? Okay, now it's the time, yes, from 1 to n, of course. But I'm going to replace this by n squared, n plus 1 squared over 4. And I'm going to replace this by n plus 1 over 2. And then do the algebra. So,
What's
yes?
I mean, it's not with this, but what's I squared? Is it n times or n plus 1 times n plus no?
N times n plus 1 times 2n plus 1 over 6. It's n plus 1, 2n plus 1, over 6. Good question. 4 over n. So I have inside 512 n cubed times n squared n plus 1 squared over 4 minus 56 over n and n plus 1 over 2. Yes, these two will go away. 512 divided by 4 and 56 divided by 2. Because I can. And this is 28. Okay. So the least common denominator is n, and I will multiply by the n in front. So it will be n squared, as expected. So limit n approaches infinity for n squared, and let's see what we get here. So 128 times n squared plus 2n plus 1. So 128 n squared plus times 2, what do I get? 256, right? N plus 128 minus, of course I ran out of room. Are you surprised? No. Of course I ran out of room. I always do. Okay.
Did we cancel that tens on the second term?
If you do, then you will have to multiply to find the least common denominator.
Oh, okay.
Yeah, you can. You can, but then you cannot subtract them because they won't have the same denominator. Okay, so minus 28 n squared minus 28n. And close the parenthesis. And no, I'm not going to multiply by that 6. Okay, so let's see what we have here. 4 is still there. I have 128 n squared minus 28 n squared, so which is 100 n squared. And I have plus 228n plus 128 divided by n squared, and I'm sure you all see the 400. Same degree over same degree. When n approaches infinity, the horizontal asymptote is 400. Rational function, same degree over same degree. Leading coefficient over the leading coefficient. If you don't, that's okay too. So I continue with limit. As n approaches infinity, it's infinity over infinity. So I will differentiate inside. So I have 200n plus 228 over 2n. I differentiate again and I get 4 times 200 divided by 2, which is still 400. Either one. Good pick. It was so nice. Thank you. Good team effort.
You also said you go with the extra credit on the last
Yes,
quiz.
yes. What was it?
It's a big F of x equals to tan x, or 2x squared to tan x. Yeah. And then the function's t squared over 1 plus t dt.
Good. So the same thing, I have to break it up into 2x squared to any number you want, plus from the same number to tangent x, t squared over 1 plus t
So,
dt.
so it's that number you put like a.
Whatever you want.
0.
Perfect. I have to swap this because I won't be able to differentiate. So this is negative from that number that you choose. Oops. So now I can differentiate. So f prime of x is f, right? When we differentiate. Okay, it doesn't really matter. So then I have negative 2x squared over 1 plus 2x squared times 4x plus tangent squared over 1 plus tangent x times secant squared. Yes, I will square this and multiply by 4x, but there is nothing else recommended here. So this is 4x to the 4th. So this is minus 16 x to the 5th over 1 plus 2x squared plus tangent squared secant squared over 1 plus tangent x. So remember, never get into that trap. So if you're given a function, it's a form of an integral. So these are the limits of integration. You cannot be asked to do anything else but just differentiate.
Can you show?
Is this okay?
So you don't differentiate. Sound like five. Differentiate, whatever. you say.
Differentiate. Yes? Good.
Uh,
So this was the function. I'm differentiating this side, and I'm differentiating this side.
Yeah.
So the left-hand side is this. And when I differentiate this side, first I differentiate the first integral, replacing t by 2x squared
Yeah.
everywhere.
Well, but don't you do that? Don't you differentiate the t squared plus?
No,
No.
no. So let's look at this one more time. So if you remember, we are given a function like a to x from f of t dt. And this is fundamental theorem of calculus part 1. When I differentiate this side and I differentiate this side, this is f prime of x, right? So I should have not used the same notation. I'm sorry, I have to change the notation. So g of x is given in a form of an integral. So the right-hand side is f of x. So when I differentiate an integral, these two go away because these are
Okay.
part of the integral, and x replaces t.
You differentiate the x on top, like if that was
Yes, times x prime. But that's 1. That's why we don't write it.
And that's why we have to flip it to get the 2x squared on the top.
Yes, exactly. Because the lower limit must be a number.
I got confused before because it's like the integral notation goes away and the dt goes away. I wasn't differentiating the x. So it's like the x becomes.
So if you have here, let's say x cubed, then you have to multiply by 3x squared.
Right, but like does that take the place of dt, and then that's how you can like. I
No.
guess that's how I remember it.
So no. Fundamental theorem of calculus part 1 shows that differentiation and integration are inverse operations. So if I differentiate an integral, the integral disappears, but it must disappear with dt. When it disappears with dt. When it appears with dt. Mandatory, yes. So that's why we do not do anything to the function. As you see, it's the function itself. We are not differentiating it. We are only replacing t everywhere by, not everywhere, here by 2x squared and here by tangent, and we multiply by the inner function prime. Is that better?
Yes. Perfect.
Perfect. Thank you. Other questions? Anything else? Yes, please.
So that problem specified using a fundamental theorem calculus part 1. Can you do it with part 2?
No, because this is a function given in the form of an integral. Part 2 it's a definite integral in which the lower limit must be a number and the upper limit must be a number. So part 2 says the integral from 5 to 10, blah, blah, blah. But part 1 says the integral from 0 to a function, or from 0 or from a, from any number, to something else that has x in it, from f of t dt. So that's why they are completely separate. Part 1 says, look, Differentiation and integration are inverse operations. Part 2 says, here is what you have to do to evaluate a definite integral. So they are completely separate. And what you have to do is you have to find for the second part, you have to find the antiderivative, plug in the upper limit, and subtract when you plug in the lower limit.
Unless it's not a definite interval, then you do plus C.
If it's an indefinite integral, a fundamental theorem of calculus doesn't apply. If it's an indefinite. If it's a definite, yes. Or if it's a function given in the form of an integral. Okay, anything else? Is there anything else that you would like to go back to for this test? Anything else? Anything else? Are we okay with this? So can I go back now to other topics, maybe, whatever else I'm hoping that still, even if you're studying for this test on Monday, I'm still hoping that you're redoing the previous 3 tests. Please, please. He looks at me and says, no. Please. It's very important because we only have 1 week left and we only have 1 session. So as I mentioned before you came in, I have set a review. I reserved this room for Saturday, December the 8th, in case you have more questions before the final.
To review.
To review. Not to review. You have to come with your own questions. I'm not going to continue saying, okay, let's do this, let's do that.
What time?
11 to 12:30. In this room, Saturday, December the 5th. But you have to come with your questions. 8th, Saturday. I said 5th?
You said both. So the 8th from 11 to 12:30.
11 to 12:30. But if you don't have questions, I won't just say, oh, either way, let's do another problem like this. Only because I will have another class in here as well.
But this will be like class spanning, not just unit 4, correct?
Just everything you will have questions on before the final.
Okay.
After reviewing the test and solutions and everything, you'll say, I need to see this, and we'll work on the problem.
For the final, we just come here normal time.
Yes,
On that
I-
Wednesday.
I will be here much earlier. I will be here from at least 2 o'clock, so you can come anytime you want.
If we show up early, can we start early?
Yes,
Oh, really?
yes,
What time are you getting here?
5th to 12th.
2 p.m. 2 weeks from today. Okay, so what am I doing? I don't want to waste time. Say it again.
What's your
Okay.
favorite stuff?
Okay, so let's go back to chapter 2. So in chapter 2, what did we learn?
Limits.
Limits, continuity, right? How to find limits or sorts,
The definition.
and the definition of the derivative, correct. So these are the major topics, okay? So you want me to choose something?
Yes.
Okay. Also, we graphed again piecewise defined functions, and we looked at the function, and then we had some questions and continuity. And so, do we start with limits? Okay. So let's start with 13,
Wait, what?
page 167. So limit as x approaches infinity from the square root of x squared minus 9 divided by 2x minus 6. You are allowed at this point to use anything that you studied in the course. So even if, so we studied the L'Hopital's rule in chapter 3, although it was part of chapter 4. So now, if you feel comfortable to use L'Hopital's rule at any point in time, it doesn't have to be, it has to be on any limit you want as long as the conditions are fulfilled. So for example, this limit comes from chapter 1. I'm sorry, from chapter 2, test 1. But at that time, we did not know how to differentiate. We did not know what L'Hopital's rule said. So the top approaches, the bottom approaches.
Infinity.
Okay, so I can apply L'Hopital's rule. So this is limit. Let's see what happens. So I have 1 over 2, the square root of x squared minus 9 times 2x. And the bottom is 2. So I will simplify. So I get limit x over 2, the square root of x squared minus 9.
Can you write, because I always get kind of confused, but can you write like in that upper corner like exactly what happens? Or just like how it's, I guess you just bring it, it's fine.
No, wait.
Well,
So,
no, I'm just like how the the square root of 2x.
so when I differentiate, so
Well,
we,
no, I understand all that. It's just the square root of x squared minus 9 going to the bottom.
okay. The square root of a function prime is 1 over 2, the square root of the function times the function prime.
Yeah, I understand. It's just that the
So when I differentiate this function,
no. I understand how you got that. I'm talking about how it becomes x over 2 times the
you mean from here?
yes.
Okay, so this is x over this, and this is 2 over 1, and I flip into 1 over 2 because I divide two fractions. This is x
Okay.
over this, and then this is 1 over 2, and I say 1 over 2. 2 over 1, and I flip it. So that's why I have x at the top. There is nothing else, and I have 2 times the square root at the bottom. Is that better? Okay. I may get into trouble here. I just wanted to see if L'Hopital's rule works. I don't know if this is going to help me or not. Maybe it's more difficult to use L'Hopital's rule than the method we studied in chapter 2. Okay, so now I have limit. I'm going to copy it here because I wrote this in the middle. So x approaches infinity. I can put 1/2 in front. Doesn't bother me at all. And I have x squared minus 9. So now, if I continue, and I will, and I'll show you, what happens is I still have infinity over infinity, but I do have a problem. The numerator will be 1 when I differentiate. And the denominator will be 1 over 2, the square root of x squared minus 9 times 2x. And again, when I flip, I'll come back to something like this. So although I do have all the conditions required, they are fulfilled, required by L'Hopital's rule, for this particular function is more difficult to even proceed than to go back to what we did in chapter 2.
Go back to the basics.
Go back to the basics. Okay. So limit as x approaches infinity, the square root of x squared minus 9 over 2x minus 6. If you remember what we did last time. So this was infinity over infinity, in chapter 2. I have to factor out. So I factor out the degree under the square root, and then I factor out the degree. I meant minus 6 over x. So, and I factor out the degree in the denominator. So then I have to think in terms of the square root of x squared when x approaches infinity. Because remember, the square root of x squared is not x. It's the absolute value of x. So the square root of x squared is the absolute value of x, which can be positive x if x approaches infinity, but negative x if x approaches negative infinity. Well, it's approaching a positive infinity, so I can take it out as x. Is this okay so far? So this is limit as x approaches infinity. X, the square root of 1 minus 9 over x squared over x, 2 minus 6, 6 over x. And these two go away. I have 1 and 1. And this is so much more convenient. The numerator approaches 1, the denominator approaches 2, and that's the end of it. And L'Hopital's rule, I don't even know if I can even get it with L'Hopital's rule, because I stopped after the first step when I saw what was happening. Say it again.
9 over x squared approaching infinity approaches 0. 6 over x.
Is this okay? Is this okay?
Yeah.
Okay, let's see. We continue with limits or something else?
Let's do one more limit. Why not?
Okay. Any preference?
Maybe one with the indeterminate case.
With the,
Is that Untitled?
you mean the ones with the log?
Oh, 1 to the infinity.
Okay, but those are in L'Hopital's rule in chapter 4. So we can go back to chapter 4 for a moment. And you can choose from page, I'll tell you where they are. And you can choose anything you want. 4.4, page 308. Any problem from 308?
Well, I thought we had learned
Yes,
some indeterminate cases in the beginning.
there are only 7 indeterminate cases.
Right.
In the beginning, we looked at the infinity over infinity, maybe 0 over 0, or infinity minus infinity. Reed was saying 1 to infinity,
Right.
and that is in L'Hopital's rule.
Okay.
But which one you prefer? We should do both, but which one would you like to look at?
25.
From which page?
308.
Okay, let's do it 25. But Paul, did you have something else in mind, a different?
No, this is fine.
61 after that.
61 after that. Okay, 25. We did 25 together. So limit as x approaches 0 from e to x minus 1 minus x divided by x squared. Good. So